Hi everyone! In this video we're going to learn one more method for finding the slope of a line. And this time this method will involve formula. But to better understand where that formula comes from, let's start by looking at this graph and measuring the slope the way we already know. Remember, the way we learn to measure the slope, if we have a graph in front of us, is by picking a convenient point, let's say right here. It's right on the grid. And by the way, coordinates of that point are, let's see, -3, +6, -3, 6. And pick another point right here. That's -2, +3. And then travel from one point to another and count your steps. So I can go 1 to the right and then 3 down. So 1 to the right, 3 down. I'll make that note. By the way, because it was 1 to the right, it's +1, and since I said 3 down, I'm using -3. So let's put this all together. To find slope, again, that's our old way. We counted the steps, but now which one is rise, which one is run? That's what we're using here. Rise is always the vertical change, so going up or down, so that's -3. That's always something that I put on the top. And then run is the horizontal change, so that's 1. Okay, like that. So I got -3/1, and of course I can simplify that and say, well, slope is just -3. But for the purpose of this, topic, I'm going to keep it as a fraction. And this is what we're going to do next. So let's, again, look at those points that we used to calculate the slope. Let me remind you that the first point that I picked was -3, 6. I'm going to call that point to indicate that it's the first one. I'm going to call its coordinates x1 and y1. So those ones, subscripts 1, just indicate that these are x and y coordinates of the first point. And the second point is, I'll call it x2, y2. That's the x and y coordinates of the second point. So here's my question. How can I find the same numbers as I had for the slope, -3 and 1, by manipulating the coordinates of the points? So -3, how can I put together the coordinates of this point to get -3? And I have x coordinate, I have one y coordinate, so which one should I look at? Well, since -3 is the vertical change, it makes sense that, and it goes along the y-axis, it makes more sense to maybe try manipulate the y coordinates. I have 6, I have 3. How do I get -3 when I put them together? Well, if I take 3 and subtract 6, that will give me -3, right? Okay, how about 1? So since I already used y coordinates, let's see how we can manipulate the x coordinates. It's going to be a little bit more maybe tricky because they're both negative numbers. How do we put them together that the result ends up being 1? Well, in this case, I'll take -2 and subtract. I'm using subtraction again as on the top. The x coordinate of the first point, -3. And the reason it's going to work because, well, numerator is 3 minus 6, but then the denominator will be -2. And then those two negatives will change to plus sign. It's going to be -2 plus 3. And as I can see then, in this case, I get -3 on the top and then +1 on the bottom, which is exactly what I was trying to get, right? The slope that I already found before. Okay, so hopefully it made sense how I was able to manipulate the coordinates of those 2 points to give me those numbers. But let's now denote what exactly we use here. So 3 and 6, where those 2 came from. 3 is the y coordinate of the second point, and we call it y2. Then we subtracted, it was 3 minus 6, and 6 is the y coordinate of the first point, y1. And then for the x coordinates, -2 is the x coordinate of the second point, so x2, and then again I subtracted the x coordinate of the first point, so x2 minus x1. And guess what? Well, that is the formula that we can use for finding the slope of a line, which means that, and I'm going to write it all together, but I just want to point out that even though we had a picture here, we had a graph of the line, this is just to illustrate where the formula comes from, but in reality, I don't even have to have a graph for me to calculate slope. What I need, I just need to know 2 points, any 2 points on the line, and then if I have those 2 points, I just need to put their coordinates in a special way. Well, that's the exact way. The y coordinates on the top, their difference is in the numerator, and the difference of the x coordinates in the denominator, and that will allow me to find the slope. Let's write this all down. So first of all, as already said, we need 2 points on the line, and we denote them as the first point and the second point. By the way, it doesn't matter which one we call first, which one we call second. And after that, this is how we're going to find the slope. So to calculate the slope, we're going to set up the fraction, and in the numerator, we're going to subtract the y coordinates of those 2 points. It's y2 minus y1. And in the denominator, we're going to subtract the x coordinates of those 2 points. Just keep in mind that we have to use the same order, right? So the first coordinates right here should come from the same point. So yeah, that's the way to do it. And we also always subtract. So both on the top and on the bottom, we always subtract. How do I write it? Maybe like that. Always subtract. It's always minus there. Let's do the following. Let's check this formula by picking some other points from that same line. We already know what slope should be, -3 over 1 or -3. And as I said, well, it doesn't matter which 2 points we have. So let's pick some points. For example, I have a good point here. It's 1, -6. It's just right on the grid, so I can easily find its coordinates. 1, -6. And what would be the other good point? Right here. So that one is right on the grid. So that point is -1, 0. Okay. As I said, it doesn't matter which one I call first, which one I call second. So this time, well, I'll go in the same order I just described them. So I'm going to call this one the first point, x1, y1. And this one I will call second point, x2, y2. And it's always convenient and it's a good practice to label your points like that so you can, you don't get confused. So we're going to check the slope by using point 1, -6 and point -1, 0. Okay, let's calculate slope using the formula. So I set up the fraction. In the numerator, I should subtract the y coordinates, y2 minus y1. In this case, y2 is 0. Minus, and then y1 is -6. So this minus comes from the formula, so it says always subtract, but then y1, that coordinate is negative itself, so I'll have 2 negatives this way. And then in the denominator, I have x2 minus x1. x2 is -1, and x1 is 1. Minus 1. Minus from the formula, and then that 1 is the coordinate. Okay, let's simplify that. Negative and negative gives me positive in the numerator, so it's just 6. And then -1 minus 1 is -2. Well, don't forget to simplify. What is -6, or I should say 6 over -2? It's the same as -3, which is the slope we already got. Yeah, we never dropped 1 here. We could, but that's exactly the same number. So see how it works. And I'd like to point out what we already learned. Remember how we said that slope can be positive or negative or 0. So in this case, we got negative slope, and negative slope is always the slope of the line that decreasing. So I just want to point out here that this is consistent for our example. We got negative slope, and this line is decreasing. So always check for things like that. This will allow you to catch mistakes. Now to practice, we're gonna do 2 more examples. I have them here, and for those examples we need to find slope of the line. passing through the given points, and then we're going to graph each line just so that we can, again, compare the slope that we find with the line we obtain. But in reality, we don't need to look at the line, so knowing those 2 points is enough for us to calculate the slope because we have the formula. So this is how I will go about it. First, I'm going to label each point as x1, y1, x2, y2. It doesn't matter which one is the first, which one is the second, but I usually go in the same order I'm given the points. And then I use the formula. Try to remember that in the numerator it's always y values, and in the denominator it's always x values or x coordinates. And that is consistent with what we know how to find the slope by taking rise over run. Rise is always the vertical change, that's why we use the y coordinates on the top, and run is the horizontal change, so we use the x coordinates on the bottom. So write down the formula so it's right in front of you, and then follow it and the numbers that you already labeled. y2, it's right here, -2 minus from the formula, and then y1 is 4. Now in the denominator I have x2, which is 1, then minus from the formula, and then x1 is -3. So since I end up with 2 negatives, I'll use the parentheses. So that's -2 minus 4 over 1 plus 3. Negative gives me a positive, and that's same as -6 over 4. Okay, so -6 over 4. We can simplify this fraction, and I can divide by 2 on the top and on the bottom. So that gives me -3 over 2. By the way, this negative sign I can either keep with the numerator, or I also have an option of putting it right in the front of the fraction. So negative sign within the fraction can travel, but I can put it anywhere, top, bottom, or in the front, but I never double it, so it always happens just once. So that would be the slope. Now I'm going to graph the line, and just to confirm that the slope is consistent with the line that I obtain. So I'll just use those 2 points to graph the line, -3, 4, -3, 4. Let's point here, and then the second one is 1, -2, 1, 1, -2. Like that. And what I can see here is that, yes, the line is decreasing, and it's consistent with the slope that I found, well, meaning that it's a negative slope. Now let's do the second example. Same thing, I start by labeling the points. So x1, y1, x2, y2. To find the slope, we'll use the formula. And I recommend writing it every time because it helps to memorize it. So let's plug in the numbers. y2 minus y1. y2 is -1 minus y1. It's -2. So middle sign is from the formula, and then each number has its own negative. In the denominator, it's x2, which is -5, minus from the formula, x1, another -5, like that. So a lot of negatives this time. Let's be careful how we simplify them. So it's -1, and then negative and negative together will give me positive +2. And same thing in the denominator, negative and -5. Negative 5 will be +5. Okay. Now, -1 plus 2, that is 1. And then -5 plus 5, they're opposites, so they cancel each other out. It's 0, like that. Okay, so I got 1 over 0 because values on them in the denominator just canceled. What does that equal to? Well, we have to be careful and remember that whenever we have 0 in the denominator, the result is undefined. So this is undefined. So it means that, well, there is no answer, pretty much. There is no value that we obtained. So how come? What kind of line is that? Let's graph it, and then, we'll remember what it is. -5, -2, that's the first point. X is -5, and then Y is -2, so it's right here. And then -5, -1. Okay, they happen to be very close to each other, but I can see how they're stacked up, so they're one above the other. So if I connect them, I obtain a vertical line. And if you remember, we already talked about how vertical lines are the ones that have no slope, so we don't measure slope for the vertical lines. And before we just, learned it as a fact, but now we could see algebraically that it's just impossible to calculate slope for a vertical line, because what happens every time? Remember, in this formula we have to subtract x coordinates on the bottom, but no matter what kind of points I'm gonna pick, any 2 points I pick from that vertical line, they will always have same x coordinate, right? The y coordinates will be different for all those points, but x coordinate is always going to be the same. So that means that no matter which 2 points I take, in the denominator, those two same x coordinates will always cancel each other out because I'm subtracting. So I will always end up with 0 in the denominator. And that's true for any vertical line. So yeah, that just confirms again what we know. So it was good to look at the graphs. However, I just want to emphasize again, to calculate slope when you know 2 points, you don't really need to see the graph.